Hello everyone, welcome back to Dragonfly Engineering. So this week we're going to do the 1-year review or the follow-up review on this no-name plastic granulator or plastic grinder that I purchased on the internet about a year ago. And I'm trying to remember if I bought it through Tool Lots or Amazon. I think I bought it straight through Amazon. But you can check out the unboxing or uncrating that I did about a year ago. And I had some concerns, and some of the viewers were interested to hear about a follow-up. So I guess some people are interested in getting it. And in general, after all of the stuff that I discovered when I unboxed this instrument, which I'll put a link in the description of the original episode, where I basically had to clean up a lot of basically machining metal chips that remained in the fabrication of this device, as well as add a ground to the motor to make the thing more safe. My initial impression was that it was not a recommended purchase, some of which due to safety concerns, plus the fact that a plastic granulator shouldn't be shipped with like threads remaining on tapped holes, you know, like spiral steel threads, and general chips and grinding swarf and grease and crud all within the unit. So I did have to spend probably an entire day deburring the machine parts, basically tear the whole machine down, and as I mentioned, fix the ground and get all the metal chips out of the machine. But once I did that, the next year of operation has been acceptable, short of a few things that I can go into detail here in a minute. I am still worried about the safety factor. For instance, you know, you can swing this gate up, and then there's a button right here that you basically prevents the grinder from spinning and taking your fingers off while the guard is up. But you know, if you accidentally have the power on and for some reason your hand rests on this button, this big steel drum with flying teeth is going to come to life and fling plastic at you or cut your fingers off. So I'm still not a big fan of that. Usually safety interlocks have a key, you know, like a special expensive OSHA approved electrical switch where a specific key has to go in, and if that key isn't in the switch, then it's not going to turn on. Here it's just a plunger. I can zoom in and show you. All right, so I got you zoomed in, and the last material that was ground was purple polypropylene parts. So that's all this purple plastic in here. But this plunger right here is the safety interlock. So when the gate is down, that plunger engages. And then, you know, with the e-stop off, you can hit the green button and this thing is going to start running. And then I assume as you lift up, which I'm not going to do, you know, this switch will stop the drum from spinning with the teeth inside of here. But it's going to take a while to spin down, and you can still stick your hand in there while that thing's spinning. So it's just, this is just not the way to go. There should be a key in here, and ideally a timer to prevent, to let this thing slow down and stop its kinetic energy and be fully safe before you actually open up the safety guard. But there's basically a weather stripping for window, so like soft foam with an adhesive back, which creates supposedly a seal to keep all your fragments from flying out the side. Yeah, so this is just soft foam, and what happens is chunks of plastic gets embedded in this foam, and then like back here at the bottom, which you can see, like for instance, that's a piece of white ABS, which was the last material that was ground in this unit. Well, all of this stuff stays behind, and then eventually when you're working it, this piece of white drops into the purple. In fact, like here's a piece of white right here that's cross-contaminated in my color. So some people just regrind plastic and don't try to preserve the color, but I run enough of particular colors where I'd like to isolate the two colors if possible. But with this soft foam gasket, which basically slowly disintegrates, like there's chunks missing, what happens is you wind up with pieces of black foam dropping into your plastic as this disintegrates. Another thing that happens is since the plastic likes to build up in this gasket area, you wind up with a big like heap of plastic like showing up in this area. Yeah, so if you get a pile of plastic in the back here, and you close the gate down, then, like for instance, that's a good example. The gap here didn't completely close. So what happens is, you know, you lock down the part. This is an exaggeration, but this plunger may not be fully depressed. So then the machine's not working, and then you got to figure out why it's not working. So that's some of the problems. But you know, this was also a bargain basement grinder, so you kind of get what you get. I think what I'm going to do is run this grinder some more and clear out this purple material, and then we can take a look at some of the other issues I've seen with the grinder. And then we'll pull this handle up, which fits into this welded on T-slot, which seems robust. And with the safety guard down and my safety glasses on, we will turn off the e-stop, and I'll hit this green button and it should start grinding. Oh, and also you want ear protection because this is pretty noisy. I am seeing some sparks come out the side, which isn't a good sign. All right. Well, there's less purple parts or chunks in here now. And I'm gonna unplug the machine now. Right, I got a little extra light on the situation. So as I mentioned, I saw a couple of like bright white, just micro sparks shooting out of the bottom of this thing. So it would be nice to know where that's coming from. Looking at this tooth here and this tooth here, I do see a little bit of a chip there. But let's clean this thing out. Again, I've shut off the power to this grinder. And then we'll check over here. Now I did have an instance where a screw got wound up in it got mixed in with some regrind plastic, and this grinder actually ground up a screw and it pretty much shredded all of the teeth. So I did have to regrind these teeth back to a cutting edge. And now and it was like a sharp edge, but after several days of grinding, I feel like basically a wire edge along this leading edge of the tooth, but I don't see any chunks missing per se. So let's check out the third set of teeth. I guess it's easier to go this way. Yeah, I see like a little nick right there. But it looks like my original grind is still intact, as you can see there. So it generally works, you know, except for kind of just the rough shape of everything. But as I mentioned, you know, you get what you pay for. So let's take apart the bottom portion of this grinder, and you can see how to clear out one color or one plastic for another one. So basically, if you want to preserve, you know, the color and material homogeneity of the plastic, then you got to go in and between grinds of different batches, you got to go in here and basically pick out all the chunks. For instance, here's a piece of white plastic that existed through the entire regrind of the purple. And that's probably white ABS, was the last material I ground in here. So you do wind up with little specks of the last color and plastic in your regrind. So you got to basically sift through the plastic and find the one out of 100,000 that is white instead of purple in this case, which can be a little bit of a hassle. Other people just don't care so much about the color, and they just wind up using black as the color that, as far as I know, masks all other color. So you just mold black parts with your regrind. Everyone's got a different approach, but I try to preserve the color the best I can. Okay, let's open up the bottom. Okay, so down here at the bottom, this is the purple that we just finished grinding. And one thing I do to help mitigate any kind of metal chips or issues that are still shedding from this machine is I have these bar magnets, these rare earth neodymium magnets, and I've just stuck these randomly in this tray to help collect any chunks of metal that are still being shed from this, because obviously you don't want to be running chips of metal through your injection molding machine. So you can also run your regrind through a plastic hopper that has a big magnet in the base, which will also collect metal chips and things if it's magnetic metal. So something to keep in mind. I was also thinking of doing like a metal detector, but I don't know if it would actually detect small little chips or not. So anyway. Oh, and stainless steel probably won't be captured by magnets either, because it's like 300 series stainless steel is barely magnetic, so it wouldn't be picked up by this. So the stainless steel screw would just go right through back into your injection molding machine. So you got to be careful. But yeah, for the most part, we got purple, and every now and then there'll be a white piece of plastic from the last run. But this is the end of the purple, so the chances of more purple or more foreign color specks being in here is lower. But I can see like pink right there, and yeah, so it still happens. This roller cart is pretty nice, and then you just dump it into your bigger container. Okay, so to pull the sieve out, there's a granulator or classifier, which is a semi-cylinder that has approximately 3/16 inch diameter holes in it, or 5 millimeters. So to pull that out, we basically release these other clamp knobs, and you hold onto the handle, which is getting loose. And then it comes down like so. Let's get the camera even further down. All right, so I got kind of a bright light so we can see what's happening in here. All right, so there's a plate in here that comes out, which is the classifier or the sieve. And this thing is what basically allows your right particle size to pass through these holes. You can see we still got some purple plastic in there with some pink and white chunks from previous grinds. So I'm going to dump this into our bin. Then I'm going to try to figure out, oh, so here, this is probably where that screw hit. Let me zoom in. You can probably see those dings right there. That was probably the screw that wound up in my plastic, unfortunately. So I think that impact is an old one. But it may be that the little spark that I think I saw like 3 individual specks of white light coming out of the bottom. I may be knocking off the high points right there. It's hard to say, but I don't see any gross like total chewing up of cutter teeth or anything. Okay, so you want to check your plate to make sure it's clear. You can get the dust off. Yeah, when you regrind plastic, you do wind up with a lot of plastic dust. So a lot of the vacuum hoppers, or the newer vacuum hopper, actually all the vacuum hoppers that I have that load plastic back into the molding machine have filter clearers, which is a compressed air nozzle on the top side of the vacuum filter. The metal or the canister vacuum that sits on your injection unit. There's not quite a HEPA filter, but a pretty fine filter that keeps the dust from your regrind in the vacuum chamber. But you have to blow compressed air on the backside of that filter to clear out the filter basically every time you run it, because all of this fine dust that you see clogs up your filter, and then basically your vacuum autoloader doesn't work anymore because its filter is clogged, and you can't get vacuum airflow to suck the plastic up from your storage container on the floor. And then we put our grate back in. I'm probably going to file down some of these edges before I run this again. But you kind of reseat your classifying grate in this holder, and then you want to clean out the rest of the crap that's basically in all the nooks and crannies of this spinning drum. But we'll pull this back up, and you want to kind of lock it in place, and then we tighten down our clamp. Yeah, so this is the second one. Same kind of scheme as this top clamp. And I've got the power off the whole time I'm doing this kind of work because I don't trust the little button. There we go. Okay, so we've, and then, you know, the little fling shield you want to clean off as well. All right, so the other problem that I've had with this grinder is this button. Yeah, the start button falls off. So I think I can show you that as well. So you open this service panel by removing this plastic hand knob, this one and this one. And then, you know, so this is the inertial flywheel that keeps your cutter momentum going to blast through the plastic. See if I can roll this around. So this button falls off a lot. This switch always falls off. The emergency stop one doesn't seem to fall off as easily though, which is good because you don't want your e-stop button to fall off your machine while you're using it. So at least they've got the e-stop kind of handled. But the start button does fall off just from the sheer vibrations when this grinder is in operation. So this screw is already loose and there's another screw on the back side, and the screw basically screws through this white or this metal bezel in the back and just pushes against the sheet metal, but there's no lock washer, there's no Loctite, there's no nothing. And I basically, whenever this back contactor falls off and the button just has nothing to push against, then you got to go in here and basically remount it. So let's see if it sounds better after I reset the grating and pulled this plastic out, because I'm not a big fan of seeing tiny little sparks shooting out of this thing. All right, let's pull this down. Again, we got to make sure there's no big chunks of plastic in this soon to be decimated black foam seal. And then we tighten this thing down. And I'll plug in the unit again. Silly me, I was trying to spin it the wrong way and I thought it was off. Even though the arrow says spin it clockwise. Okay, now it should start. All right, that sounds better. Normally if you got a chunk of metal in there, you'll definitely know it because it'll just sound horrible. This sounds about normal. There's just some panel is vibrating somewhere. So let me shut it off. Yeah, so you shut it off with the e-stop button. So I guess for the I think $2,000 I paid for this thing, it's functional, but it's probably not the best in the world. I think it'll get you by, but you have to definitely be careful about metal contamination getting back into your injection molding machine or whatever process you're using after you regrind this plastic. So I wouldn't recommend it unless you're on a tight budget, which I have been on a tight budget, but now it probably makes sense for, if I were to do it again, I'd spend, you know, $5,000 to $8,000 on a grinder and reduce the risk of causing $10,000 to $15,000 damage to your injection molding machine by basically jamming metal up into your auger screw of your injection unit. Anyway, so I guess that's my review. I don't recommend it unless you can not afford anything else, and then you've got to spend a few days fixing it up before you use it for any kind of production that you're going to run with. April and I do have some footage of us grinding up a bunch of white ABS parts, and you'll see some of the issues that we had. I don't know if I still have one or not. But we had these big white squares, like a square plastic frame, and it would, when we drop the plastic frame into the chute, it would actually lay flat and then not actually fall into the grinding section. So we had to develop a technique to kind of launch the parts edgewise through this safety flap and this labyrinth protection area, so that the edge of the part would catch into the teeth, and then it would just be drawn in and shredded instantly. But we were getting parts that would lay flat, and then all the rest of them would pancake on top, and it wouldn't actually grind anything. So little things like that. But you can check out footage at the end of the episode here, and it's It's just kind of, I'll probably just time lapse it. But if you like seeing stuff grind, then stay tuned for that. All right, so I have a few other updates in this episode, general shop updates. One of which is that I recently attended, or went to, and then attended a online auction here in the local San Jose, California area. And I wound up purchasing this old Jet metal cutting saw. It's a variable speed one, which is similar to the Dual saw that I bought about a year ago. But this one was a saw that I really wasn't aware of its existence. I was actually going to potentially buy another milling machine from this local auction, but the prices kind of went through the roof on the milling equipment. But what was interesting is a lot of the people at the auction were going there to buy high ticket items. And this was an entire machine shop that basically shut down. So they had probably 6 or 7 Haas CNC mills that were like probably 2015 era. So really good equipment. A forklift, which I bid on, but I didn't get. But unfortunately, I did get the person lift that, you know, or the cage that you can stick in the forklift tines and then lift up to have a person work on the ceiling. So I got the forklift safety cage, but I didn't get the forklift. So because you can't back out on a online pre-bid. Once you bid for it and no one else bids, then you buy it. So I bought that cage for like $50. This saw, I want to say I got it for $300, and it's a variable speed metal cutting saw. It's a Jet vertical bandsaw, and I believe it was made in 1978, according to the tag here, in Taiwan. So it's not quite as old as me, but it's pretty much around the same era as I existed. So yeah, it was cool. I don't know if anyone else bid on it, because what happened is I went to the pre-auction to look at the equipment the day before, and I saw this saw and power cycled it and used the interesting blade speed control, which is one huge lever on the side, and it worked. So I figured, well, let's throw a bid down while we're here. And then the auction happened online the next day, and I actually wasn't at the auction because it was an actual auction with the guy rattling on the auction gibberish. And the auction lasted for like 4 hours. But I was working, so I got up and left because the main thing, like the milling machine that I wanted, went for like 3 times what I wanted to pay for it. So I left, and when I came back, I saw that I won this saw because no one else bid on it. But it's yeah, it probably weighs about 700 or 800 pounds. It's like solid welded plate steel and castings. So yeah, maybe we'll get this thing vertical and we'll see how it operates. It also has a blade welder on the side, which seems to be in more working condition than the Dual blade welder on the other saw. And the reason I bought this saw is mostly because I want to have a saw that cuts metal with a fine tooth, where the larger Dual saw is twice as big as this one. And that one, I want to have it dedicated to larger pitch tooth, so cutting thicker stock. And then this one can cut the thinner stock. You know, because if you have too big of a tooth, I think it was this old Tony who recently said that you want to have 6 teeth in your stock. But if you've got like a 1/16 piece of like tool steel that you're trying to cut in half, and you've got like a 6 thread per inch tooth, basically what happens is you're going to shear off all the teeth, and then eventually one tooth is just going to deadhead onto your steel sheet metal and then knock the whole blade off the tire or the wheels. And that basically happened. So I did ruin a blade, and that kind of led me to wanting to have 2 saws, one that has fine teeth, the other that would be large teeth. Both are variable speed for cutting metal. Before I did any of these saws, I just had like a Home Depot wood cutting saw that, you know, goes at maximum like 2,000 feet per minute, and is built for plastic and wood, not metal. So it in itself would burn up a bunch of of blades and just by going way too fast. All right, so I'm gonna lift this thing up, and you can join me. Hopefully it'll go better than the Dual did, where it kind of crashed vertical. Oh. So let's see how it goes. I guess I need to move the 3-phase rotary phase converter Frankenstein setup out of the way. I actually had to move this into my industrial shop out of my garage recently because someone called code enforcement on my garage. Fortunately, I had already moved my machine shop out of my 2-car residential garage and into this industrial space. But yeah, so the city showed up and they wanted to look inside of my garage. Fortunately, I had to make an appointment first, and this thing was bolted to the side of my residential garage, and the permits were questionable about it. So I figured the building inspector probably wouldn't appreciate seeing this questionable permitted Frankenstein monstrosity on the side of my garage. But anyway, they violated me because of a electrical panel that was in there, and there was no record of a permit pulled for the electrical panel, and I don't quite remember exactly when or who put the panel where, but anyway, that's another story that we may get into in this episode about what I'm doing to the garage at the house. But for now, I got to move this thing out of here. But I did want to, I guess, briefly tell you about the evolution of this setup. And it is American Rotary, but unlike the other YouTubers, I am not sponsored by American Rotary. In fact, I'd probably go a different direction in that I may actually bill American Rotary never to show this in more detail in future episodes. But we'll see. I doubt they're going to contact me. But just so you know that if you do get a rotary phase converter, like a 10 horsepower, which is this motor and this cabinet, you get, 10 horsepower worth of work out of it. The issue is that at some point after I had the single 10 horsepower, I bought a used injection molding machine with a 10 horsepower induction motor in it, but a single phase converter could not spin up the motor for the molding machine. So it would stall out. That motor would actually just vibrate, but not actually turn over from the back EMF in the electrical lines from the 10 horse motor in the molding machine attempting to start up. Because induction motors have something called inrush current, and most house or industrial circuit breakers allow for 100% more current to pass through them for 1 or 2 seconds to allow a motor to actually spin up, to build up the inertia of the rotating mass. That first 2 seconds of just getting up to speed requires twice as much current. So you can't get a 10 horsepower piece of equipment unless it's like a stepper motor or like a DC drive or a VFD type of modern machine. But old induction motors, they need 20 horsepower to get a 10 horsepower motor spinning up and running. Once it's running, it should be fine. But anyway, so what I wound up having to do is I bought a second phase converter, this one, and a second motor, a second 10 horsepower motor. And with phase converters or rotary phase converters, you can actually synchronize 2 of them together to create one 20 horsepower phase converter. And of course, you need to contact American Rotary or contact a licensed electrician to wire this and figure it all out. So don't, listen to me and then go and try it yourself, because you can run into problems, especially if you get the phases wrong. And I'll tell you what happened. Well, I'll tell you right now. So if you do flip the wires, so phase 1 is not synced up to phase 1 on this motor, but phase 1 on this motor winds up on phase 2 of this motor. Then when you try to start up your second motor, when the first one's running, the phase locking can't happen because they're actually going in opposite directions. So what happens is basically your second motor will try to all of a sudden spin the other direction. When you close the synchronization circuit. So let me digress a bit. The way you can lock or synchronize phase converters is you get the first motor spinning and the controller is fine and everything's happy. And then without the three phases connected to the two motors, you then start your second motor and you have that one spinning up at full speed. But it's spinning at a random clocking to the first motor because they started it at different times. But then what you can do, if your phasing is matched between the two motors, is you can basically close the circuit between the two phase lines, or between the three hots, and assuming your phases are both clockwise, then the second motor and the first motor will start to lock into each other, because they'll feel back magnetic resistance until those phases are all tied together. But if it's backwards, then the second motor, when you flip the switch on to sync the phases, if it wants to go backwards, then the whole motor will actually physically spin about 180 degrees on the floor, and then everything will be locked and it'll be a disaster. So hence you want to have an electrician or American Rotary do all that for you. Again, I'm not sponsored, and they probably would rather not talk about this. Anyway, so I wound up getting two phase motors synced, and then you close the circuit between the two, and then they sync up perfectly. And then, unfortunately, the injection molding machine motor didn't still have enough with two of these motors to actually spin it over, because it was an older machine as well. So I had to buy a third phase converter and then do the same thing again. So the startup sequence is you start the first phase converter, the first motor. You then start the second phase converter and the second motor, who are not synced. Then you close the circuit between the two, and then those two motors will phase lock, and they'll be spinning exactly in the same phase. And then with the third motor, you then turn on the third phase converter. The third motor is spinning up, but it's still not locked to the first two. And then you close the second circuit here. Let me lift this up. So these two are spinning and synced. This one's spinning, not synced. And then you close this contact box, which will then short basically the phases of this motor to these two that are already synced up. And then this motor will then sync with the other two. So you wind up with three motors that are spinning with their phases all synced up and locked together, and they're spinning in unison. And that was enough to, with three of them, to get the old molding machine to work. But then I just, moved out of the garage altogether. This was still on the wall for another 5 or 6 years. And then I had to basically remove it before the building inspector showed up. So now it's here in the shop, and I'm probably going to dismantle it. I don't think I can sell it because, again, I'm not a licensed electrician. But I may part it out and sell individual phase converters if anyone's interested in a used phase converter. All right, so let's get this out of the way, and then we'll lift up our saw to be vertical using our manual forklift. there we go. Man, it took longer than what I'll probably show in the edit. But leverage is always a good thing. Yeah, this is the lever I used to tip it up to vertical, and it worked. So now I got to pick it up with this manual forklift and then take it over to the machine shop side of the shop. We're in the warehouse right now. We got it. Okay, still got the auction tag on it. Now, of course, it makes a mess. I'll have to hit that with acetone or something. Lot number 45. Okay, again, I gotta fix the light up here, and there's no bulb in it. So this is the main power, and we're cutting. Now this is a metal cutting saw, so it's got a slower speed. Looks like someone in the past had a little issue. Let's see about the blade guard. Oh, that moves nice and smooth. And then there's a handle on the side over here that I'm tightening. All right, well, it cuts wood. Here's a piece of aluminum. I think we're at the highest RPM. I'll show you that in a second here. Okay, we'll try out the aluminum. That's pretty good. Makes a pretty good cut there. All right. Now we'll show the speed control, which I did test at the auction preview, which is over here. All right, so here's the speed control over here. It's high, medium, low, with 120 volt input, which I guess this, let me fix this grommet right here, or I'll have to put a proper new strain relief panel grommet here, but yeah, anyway, that needs some work. Yeah, and you basically unscrew this knob and you can basically arc this knob from high to low, and then the blade speed changes real time. I'm pretty sure you need the saw running to adjust this, so let's hit the start. And then you can loosen the knob, and then you just kind of push down. And now the blade speed is at the low speed, and then you can lock it back in place. So that is, that's the slow speed. Actually, we'll speed it up now. And this is gonna be moving up to high. It's not a huge difference in RPM, or surface feet per minute. Let's go down again. Yeah, so that's a pretty slow cut, which is nice for steel and things like that. We'll go up again. There we go. If I can get all this in one shot. That's pretty neat. Really slow RPM. So, that worked. All right, we'll have to see what works with this blade welder. The grinding stone is free, so that's good. Doesn't seem to be much action on the grinding stone power. And this is welding lamp. And ain't no action on the welding lamp. The indicator light's not on either. Let's see. There is a light bulb in here. So I can pull it out. Oh wow. And you know, the element is still good, but this is one old bulb. Yeah, take a look at that bulb. But the filament does seem to be intact. So I think there's a bigger problem with this entire welder circuit. Maybe a fuse blew inside. I don't know, we'll have to figure that out. But nothing seems to be working on it. So, like, this whole side seems dead. Could be something to do with that frayed wire I saw. All right, so now we're here in the bottom. We got this nice wheel with a rubber tire on it, which seems to be in good shape. It's got a backstop and plenty of wooden brush here. To clean off the tire, you know, there's a rubber ring that gives grip to the blade. And then there's a chip, I guess, funnel here, and then a big chip tray down here, which leads to like a square hole that supposedly chips will work their way out of there. I guess I could set up like a saw or something, but, or not a saw, but a shop vac to suck this stuff out. But I guess they're thinking it's just going to fall with gravity, which, you know, when I got the thing, it had like a wad like that on it. So not sure if that's actually useful or not. And then there's this gear right here, which I'm not sure exactly what this gear does. It almost, you know, and it comes right off. It almost looks like it's cast iron, like rusty cast iron, but you'd think it'd be steel, but I don't know. Let me see if I can figure out what it is. Can you guys see that? Like this gear here. Do the old bite test. Yeah, it's definitely cast iron, but oh, now I'm gonna have to braze that back. Let me put that back. Oh well, more work to do. Okay, well, I think that'll be a wrap for this week. I'd like to thank everyone for watching. Oh, but I would like to show a couple of other items. So this hydraulic press, just a frame hydraulic press, probably from Harbor Freight, is another item I got for like probably $50 on this auction. And a few of these pedestal grinders as well. I think this was like $25. They're basically the minimal starting bid. So yeah, these auctions are good if you want to clean up on the, you know, the accessory stuff in the auction, maybe not the big ticket items. And then next week I'll do more of an update on the dual saw. It was actually down for a little bit, but at Christmas time my dad came and showed me an obvious to him fix to the motor starter. So I'll point that out. And there's also going to be a lot of work on the new garage edition, which was fostered from the code violation that I got on my garage. So I'm going to actually expand the entire garage with water and sewer and everything. So that'll be fun, and that'll happen over the summer. So stay tuned, and thanks for watching.